Time. We think that with automation we will have more of it, but we never seem to. No matter what you do, time gets consumed at a very steady, even constant rate. When you are managing a project, time is the only resource that is totally beyond your control. Or is it? This video will give you a valuable overview of how to use the 6 main processes involved in project time management. As with all project management activities, the more planning up front, the better off you'll be. In this video, we'll look at the following topics: defining activities and then sequencing or ordering those activities, estimating activity resources and durations, and developing and then controlling the schedule. Project time management is about how the time involved in a project will be spent and how much of that time will be required, which activities will get the most time, which activities will come before others. To find out, we create a schedule. Let's say we have a project to develop a software application. The project charter has been finalized and approved. The project scope statement has been signed off on. The work breakdown structure, or WBS, has been drafted. Now we're ready to define each activity. Gathering requirements might be on the WBS along with the other typical software development steps. List out each of these activities. It could be that one box in the WBS is really multiple activities. Next, we want to order or sequence the activities. Typically, gathering requirements will be first, testing will be after development, and etc. When a late activity depends on an earlier one to finish before it can begin, there is dependency relationship between the two. Use a network diagram to show this relationship visually. This is the preferred technique and is a good way to get the project team to understand what has to be done first. You might think that now you're ready to see how long this project will take. Not quite. First, you need to see what types of resources and how many of them you'll need. To do this, you'll need the following inputs: the activity list, activity attributes, organizational process assets, enterprise environmental factors, project management plan, and a knowledge of resource availability. The goal is to produce a resource breakdown structure document. If you are successful at estimating resources, then you will be sure that you have enough resources without waste or paying too much. Now that you have the resources listed, you're halfway there. Next, you need to know how long you will need those resources for. This is the activity duration, or the actual amount of time worked on the activity plus any elapsed time. Avoid confusing the concept of duration with effort, which is the number of work days or hours required to complete an activity. So after you know what kind of resources you need and how many for how long, then you're ready to create the schedule. Charts or diagrams are often used to depict project schedules. Gantt charts show project schedules with milestones. Gantt charts were often used in the 1920s, notably so on the Hoover Dam project in 1931. Other tools and techniques are used to analyze activities and resources, and we'll go into a little more detail on some of those now. The critical path method is a network diagram technique to project how long the entire project will take, or the project duration. This can be a very useful way to avoid a schedule overrun. The diagram shows where the critical path is as well as any available slack in the project. The project team can see this visually, which brings together what tasks must be carried out and in which order, as well as what resources are needed. Ultimately, the diagram shows the shortest time in which you can complete the project, and that is the answer you really want to know. The critical change schedule method is another technique for finding that magic answer of when will we be done. This technique revolves around the availability of limited resources and builds in buffers to protect the project completion date. PERT analysis, or program evaluation and review technique, uses a combination of critical path method and weighted average duration estimates. This is the tool to use when you are not sure how long each activity is really going to take. PERT uses time estimates in a formula as follows. PERT weighted average is equal to the sum of optimistic time plus 4 times the most likely time plus pessimistic time all over 6. PERT analysis and the critical path method, two mathematical schedule models were both developed in the late 1950s. PERT was created as part of the U.S. Navy's Polaris missile submarine project. Critical path method was developed by DuPont and Remington Rand corporations for managing plant maintenance projects. You can use any of the above techniques to develop the project schedule. Once the schedule is created, then how do you control it when things do not go as planned? Controlling the schedule is probably the most heavily used process in project time management. How do you know when the schedule has actually changed? And how do you manage these changes when they occur? There are several tools and techniques to use for controlling schedules. First, there is progress reporting. Progress reports include current schedule status with such things as actual start and finish dates and remaining durations on unfinished activities. If you know there will be a change to the schedule, it is best to get it approved ahead of time. Set up a schedule change control system. It should include the paperwork, tracking systems, and necessary approvals for authorizing changes. Schedule variance and schedule performance index are two common measures to assess the magnitude of any project schedule change. Performance measurements techniques produce these numbers, which help the project team decide if any corrective actions necessary. The schedule should be monitored, and variance analysis is a key part of this process. Comparing target schedule with actual versus forecasted start and finish dates helps detect deviations. Schedule bar charts can also be used to detect these variances. This is a chart with two bars for each schedule activity. One bar shows the current actual status, while the other shows the approved project schedule baseline status for that activity. You can graphically see where the slippage has occurred. Doing this analysis and creating charts is well and good, but the real bonus here is that there are several offerings of project management software that will do this for you. These tools can track actual versus planned dates and can forecast the effects on the overall schedule. They use standard methodologies such as techniques discussed in this video and can create visual interpretations of project data in a few clicks. Programs such as Microsoft Project can be used from very first process, defining the activities to the last one, controlling the schedule, and for every process. The future holds a pressing need for project time management skills. Globalization and economics are creating projects that truly span the planet. Teams are distributed around the world. Projects are becoming larger and more complex. But there is still the question of when will the project be done. New techniques and better practices will evolve to meet this demand. But for now, it is uncertain how. Hopefully the information in this video has allowed you to get familiar with the current processes involved in project time management. Thank you.